joining. This is, did you say it was the number 41 of the series? Yeah. And for Community Conversations with Jacob and Saul. My name is Tiana. I am going to be hosting in terms of the community team today. Let's see. Oh, you're originally from New Zealand, Saul? I didn't know that.
Yeah.
That's a fun fact.
I've also lived in Scotland and England and Canada, and now live in the US. So take you touring around the English-speaking world. We'll get somewhere funky eventually.
Thomas says we cannot read the chat.
Okay. There's a webinar setting that we have to change, and I can't remember where that is.
I think I have it. Hopefully, let's see.
Looks like everyone's just responding to hosts and panelists.
Yeah, I just tried to change it to everyone, so hopefully that works. I will play around with that, but in the meantime, again, welcome to those of you who are rolling in for this community conversation. Oh, okay, David can see it now, so I think we're all set. We're good.
Awesome.
Hopefully. I will keep an eye on that just in case. But again, hello everyone who's joining. Feel free to drop where you are from, where you're tuning in from, and any other fun facts about yourself that you might want to share. We're going to get started here in just a few moments. I know probably in about a minute or so. There's a lot of content, I'm sure that's all, and Jacob have that one. We want to make sure that you guys have enough time. So yeah.
Cool. Yeah, the content today is mostly in Dynamo, actually, less presentation focused on this one. So it should be fun. Thomas says David can see it because you are the host. Attendees cannot see attendees.
Okay, I will play around with that in the background here, so don't mind me. Little technical hiccup. Attendees can chat with everyone. Hopefully that might have done it.
David or Thomas, can one of you just type anything in there? And if David could confirm he can see Thomas's thing, and then we're good.
I think hopefully, yes, we did it. Okay, so I guess we will kick this off and get this rolling. So welcome to Autodesk Community Conversations. If you are new to Community Conversations, basically what we have here is a couple of experts that come and share their knowledge on the products that they have, and it's hosted by the community team. And yeah, we run quite a few of these. I know Saul and Jacob have been doing it for a while now, but we also have some other ones outside of this one. So if you guys are interested, we do have links that will be shared in the chat in a little while to see if you guys are interested in others. So yeah. So this is the safe harbor statement. Basically what this is just us making sure to tell you guys that you cannot or should not make any any purchases based on anything that is said in this conversation, and any forward-looking statement based on new information and events should not influence any of your purchase decisions. So that is what that is all about. Again, I am Tiana. I am a community program manager here at Autodesk. I am based in New Hampshire, good old Manchester, New Hampshire. And I have 2 golden retrievers that may or may not pop up during this. So if you hear them or see them, they're just here for a good time. So I will hand that over to Jacob and Saul to introduce themselves.
Cool. And I am Jacob Small. I'm a technical consultant based out of Boston, Massachusetts. I describe myself as a Dynamo Forum junkie because you see me on there way too often, as anybody who's been there can likely attest. So,
not just one of you, Jacob. We've seen multiple Jacob Smalls on the forum, actually. There's been some cloning going on or something. Hello, everyone. I'm Sol. I'm a product manager working on Dynamo. I describe myself as a curious human being, currently based in Boston, but originally from New Zealand.
So I'm gonna basically let you guys read the slide, but before we begin, feel free to interact through any of the reactions that are available on Zoom. You can see where it's located by the picture that is there. You can enable live transcripts if needed, as well as go ahead and use that raise the hand if you have any questions or things like that. We'll be sure to make sure that you are heard and get your question asked. And then the chat is open, as everyone knows now. We can all see it, and you guys can use it for any comments, concerns, questions. I'll be making sure if any questions go in there that Jacob and Saul see it. This session will be recorded. The recording will be posted on the Community Conversations event page, which is where you hopefully went to register. And then it will also be posted on YouTube as well. So that is that. And definitely don't be shy. We love questions and we love hearing your guys's interactions and stuff like that. So don't be shy.
Alrighty. Welcome, everyone. Thanks for joining us for the 41st session of Dynamo Office Hours, rising to the occasion. So if you were with us last time, we built a funky stair inside of Dynamo and pushed that into Revit. Something that was not necessarily, your standard typical stair. And what we're going to do today is basically play with it, explore it, make some changes, add some more detail to it, and sort of get to a more holistic place. And then session after this, we're looking to do something with documentation. So definitely come along to that. So as usual, we have around about today we have about a 5-minute presentation in the deck, and we have like a, up to 50-minute presentation inside of Dynamo. So we would encourage you to please talk to us as much as you can, ask questions. Totally encouraged to ask questions about Dynamo in general. Doesn't have to be what you see on screen. We really, really enjoy conversations. We really enjoy going down rabbit holes if they're useful to other people, especially. So please do hit us up in the chat. We will read your questions back out loud so that the recording can capture them. So this live demonstration is going to be the bulk of it today, and the Q&A, please do intersperse that between what we're showing.
Cool. All right. So last time on Dynamo Office Hours, we built a crazy stair. So this is an animation that holds the deck that basically shows how it was intended to work. You can see the graph over there on the right. We set it up to basically drive all the math that is required to build all the different shapes and get the individual treads pushed over into Revit kind of all automatically. I actually recorded this while I was filling up a cup of coffee, believe it or not. So it was one of those things where you hit run, walk away, come back, and hopefully things are looking better. And in fact, they were. So
in this case, Jacob, you don't want to walk away because you get to see this awesome animation happening right in front of your eyes.
That is true. That is true. Now, I will spill the beans a little bit. That was the 4th round at trying to get the animation centered. So yeah, I stopped watching after the 3rd one.
Fair enough. All right, so we have about 5 slides today. So we are supposing a situation here where the client enters in after we've done this really cool conceptual design and they change their mind a little / a lot. So the stair looks great, but what if we actually wanted to make the atrium twice the height and remove an entire floor there? Or what if we really wanted to do 2 full rotations just because it's cooler and we want to? And while we're at it, why don't we start thinking a little bit about detail? Maybe you want to add things like non-slip treads or surfaces. Maybe you want to put some safety aspects in there as well around like handrails so you can hold on to something. And then at nighttime, it's going to be a little hard to navigate without lighting. So maybe you also want to put a bit of sconce lighting inside of the stair as well. So it looks perfect, but 3 pages of changes upcoming. So what we're going to do is go through the changes because design is iterative. So we're going to talk about flexing the stair proportions, stretching to span 2 stories. It looks like Jacob doesn't have my emoji, that face. Sticking on some non-slip surfacing, adding safety with fancy railing, and illuminating with sconce lighting. So what this actually means is we really want to be able to build a stair that actually works. So within the bounds of Dynamo, you can flex your stair in a way that maybe not sensible, credit to the image on the right here. But what we want to do is sort of limit those bounds to make it something that is sensible and then explore within that space. We are also going to stretch it to span 2 stories. So this is the taking out that giant chunk of floor above the stair. Pretty straightforward on that one.
Ginny looks like she has her hand up. If you guys are willing to.
Yeah, of course.
Perfect. She should be able. Ginny, you can come off of mute if you want, and ask your question if you have one.
Hello, Ginny.
Doesn't see. If you have a question, you can go ahead and put it in the chat, but we'll keep it moving.
Cool. Okay. If you have that question, Ginny, please do feel free to just sing out or write something in the chat. We're more than happy to answer it. So the last couple of slides, we have non-slip surfacing. So we don't want our stair to be a trip hazard. We don't want it to be dangerous. What we want to do is start thinking about some of the actual sort of legal and technical requirements around a stair. We're going to put in some non-slip surfacing. We also want to build in a handrail. This one's cooler than the one we're designing. Sorry, Jacob. But we're doing something kind of cool, especially in the context of a circular sort of stair. And then the last one is around, we actually need to put something around lighting, introducing into the space for this kind of dramatic effect. If we had had the chance to render it, which I don't think we quite did, but maybe we'll show that next time.
All right, so that summarizes to where we got. So we're going to cue up the danger music, and it is more dangerous than usual this time out because we're really going to be pushing Dynamo to the limits. So as you can see, I am in a file with nothing up my sleeves. Right, I don't even have a single generic model family type loaded in yet. We're going to go ahead and pop over to Dynamo, and I'm going to open the generate staircase graph that I'd set up before. So some of this will look the same as what we saw before. A lot of it won't. Even back on the early aspects of the design, things started changing pretty quick. We've got some Python to cover. We've got a lot of work with topology to talk about. So lots of stuff going on. And so you can see here, previously we had actually less than what we had up above happening, and we have all this stuff down below happening as well, which is
doubled, maybe more than doubled in size.
Significantly larger, but part of the reason for that is previously we were leveraging custom nodes to really sort of move massive amounts of data and allowing us to make use of list levels and lacing to ensure that things are kind of happening consistently. But didn't really want to do that for this round of the demo. So we sort of backed that out. For now, we're going to go ahead and talk about kind of what things are happening here in terms of the changes. So the first big change is we added some inputs for the handrails. So you can see the handrail inputs right down there, as well as another input for the non-slip offset factor. And then one other input got added in for the treads and riser design as well, with the staircase rotation. So currently that's set to 360. So we're going to go the full loop, but we're going to try that up at 720 just to see what a double loop winds up looking like as well. To facilitate those changes, I did have to issue an update to the Stereo-eyed package, so you can get that up on Package Manager. It's called Stereo-eyed. It's got 2 nodes in it, Generate Treads and Generate Portal. Generate Treads now has the overall stair rotation angle. We also made a change to the Generate Portal so I updated to Revit 2023.1 about a week and a half ago, and there's a lot of great new geometry changes which enabled a lot of the cool new functionality that we're going to talk about today. But it also meant that I had a issue was introduced into this node, so I had to make a change to extrude a polycurve the other direction, so a negative one got multiplied in a little bit earlier than before. But in any case, it does work now for you if you have that older or newer version. If you have the older version, you're probably going to need to work with the previous version of that package. So right off the bat, we'll go ahead and we're going to just hit run on this. Actually, before I do that, let me make sure I've got my gate closed, which is over here. That is closed. And so we'll go ahead and we'll hit run, just to have a look at what the stair looks like.
And we can place bets in the chat to see if we're going to crash Revit today or not.
All right, so we got some of the stuff that I wanted to show actually popping up there, but I have my wrong geometry display set up. So we're going to come over here and I'm just going to preview this and not preview that. All right, so you can see lots of new stuff has kind of popped up in here. We're going to go over kind of what all those changes are right now. So right off the bat, the first thing that we talked about, Sol, was actually changing the height. We wanted this to be 2 stories tall, right? So I'm going to come back here and I'm going to look at my sliders and we're going to find our floor to floor. And so, yeah, floor to floor is 12.5, and then we've got another 12.5 on top of that. Add those 2 up, and I think I get 25. So we'll go ahead and we're going to hit run with that. And so now we should see twice as many stair treads generated, which will be pretty nice. Now I do see something in the chat there from Thomas. Revit users have started to model stairs a lot as in-place families because the Revit out-of-the-box stairs are often limited in functionality. Was your stair creation method with Dynamo tested in Office and transitioned to Revit, or do you think it's not suitable for normal Revit users? So if I was to have this particular staircase in front of me as part of the design, and I was sort of given the option of figuring out how to fight the Revit stair tools to get them to work and make these shapes, because it's maybe doable, but it would be really tough. I think I would go the route that I went. And again, that's just because this is more of a sculptural element than sort of your typical functional stair. Most functional stairs and even a lot of the sculptural stairs can be modeled pretty effectively using the Revit stair tool, and it'll actually save you time, both in terms of the initial setup and in terms of the end result. But this one, yeah, that was going to take quite amount of effort. Now we can't see, we did get an error here, and I actually got it pretty early on with a bunch of nulls here. And the reason for that is we just can't make stair treads that narrow with that sort of size. So we're actually going to go ahead and, while we're at it, change this value to 720. And then we'll hit run again. And then we'll go back to speaking some more about the stairs. So yeah, anytime I have any kind of detailed sculptural work, I tend to go to non-standard Revit modeling techniques, be it Revit API, be it Dynamo, be it a combination of the two, which is actually what we have happening here. So we should be, we'll talk a little bit about both of those. Like you can see the handrails there. Those are not just direct shape by geometry or family instance by geometry nodes or family type by geometry nodes. I actually had to go in and do a good amount of Python work to get those to model correctly. So lots of benefit to being able to do that, because it gives me a lot more sort of flexibility than what I'd otherwise have, while simultaneously giving me a good amount of sort of leeway in terms of the design processes. So
yeah, but to add on to that, Thomas, and anyone else who's curious, it's like, you know, tools are tools, right? At the end of the day, and so the Revit stair tool is a tool, and if it does the job, great, use it by all means, because it's very good at what it does do. But if it doesn't quite model what you're looking for, in this case, sort of more organically shaped stair, then there's alternative pathways that you can take, such as Dynamo.
So you can see by expanding out that piece, I now have enough space to actually sweep those treads, and I can get that content all the way up there, so we can accommodate that sort of double-story high staircase. This is starting to feel a little bit like something out of Swiss Family Robinson to me, where we got sort of the walk up around the edge of the treehouse, but it's still really, really cool looking. The next bit of change to go over is the railings. So there's a couple different ways you can start to add additional content on there. Railings was next, right, Saul? I can't see that.
Yeah.
All right, cool.
I think technically, yeah, non-slip surfacing, but it doesn't matter.
All right, we'll do railings first. So I went and I pulled the information that I added into my dictionary before, and instead of going and trying to derive the sort of curve that I need for the railing from the model that I've already just created with the individual treads, in this case, I said I'm just going to do the math, because this node is more or less a copy of what's happening inside this custom node, right? So I can copy paste that out and then utilize a point by cylindrical coordinates, because I know the start angle for each one of those points on my handrail. I know the heights for all of my handrail, which is my elevation, and I know the offsets from the center point of that cylindrical coordinate system. So I can quickly march that all the way around and get a series of points. I'm going to go ahead and turn off my geometry preview for most of the stair, but I do have that handy little debug tool that I built in last time. Here we are.
Very cool node, the cylindrical coordinates one, and the spherical coordinates too. I think both underutilized, actually.
Extremely underutilized, I would say. So you can see here, I now have kind of exposed those sort of two sets of treads. We're looking at just a couple treads on the inside of the stair. We're not looking at any of the outer treads, but you can hopefully imagine where they might sit. But this gives me kind of a good way to sort of start to visualize this content. So from there, with these points that I've created all the way through here, I can then start to draw some curves. Now, I did go ahead and draw a NURBS curve by points here, and then a profile at the start of the NURBS curves based on a plane for the circle for the handrail, and then generated a solid by sweep and generated a post that sits in the middle. So I had something to mount that interior post handrail to, and then made sort of one list of solids from that. I don't need to do any of that though, because if I take that geometry, those solids, and I bake them in as a direct shape, we get a whole bunch of nasty tessellation that happens, alternative, which doesn't really look good. It doesn't necessarily cut well. If you try and move it over as a family, an import inside of a family, the imports actually break quite often with these really sort of twisty pieces where it's like, hey, it's a mesh, it's not an SAT, so I can't really import it as a solid. And so you're pretty limited. So what I wound up doing instead is this bit of Python. And we'll go over that when we get into the baking, but I'm gonna go ahead and double click on it to open it up so we can sort of see kind of what the inner workings of this might be, assuming it doesn't want to crash on me. Of course, it's
I believe
10 minutes in, there we go. So there's a pretty good amount of stuff that's happening here. We're working in multiple documents concurrently, right? We're up to 150 lines of code with all the annotations and everything. But it's some really sort of useful stuff, and we'll get this posted up onto the community hub later. All right, so now that covers the kind of creation of the geometry color objects and the stairs. The next piece that we wanted to talk about in terms of life safety is right underneath that. We had sort of the anti-slip tread surface, right? And so the way that I built that was I took off the existing model, right? So we generated those treads, and I quickly said, hey, from the tread, pull all the faces. I'm then going to take that face's surface geometry, so the actual surface itself, not the reference to the part of the other geometry in the topology library. And I'm going to get the normal at the midpoint of that face. I'm going to pull the Z value of that, and I'm going to check to see if that Z value is equal to 1. Is this surface facing up? And if it is, then we want to keep that. If it's not, then we're going to filter it out. And then pull the first item in that list, which happens to be all of our treads. So we can preview that, maybe. Oh, those are my edges.
No,
Sorry
they're
about that.
edges, so they're invisible.
Here we go. More edges and then into lines. So you can see I now have all the lines for the front edge of all of my treads all the way up the stairs. With that content, I can then go ahead and offset, use the curve.offset mini, which is one of the new nodes in 2.16. So this is new to the Revit environment. Generate a surface by lofting between the individual pairs of curves, and then thicken that surface to get me a solid, which looks like this. I'm going to go ahead and turn off the previous line geometry. And you can see right there kind of how that sits pretty well and clean on the front nosing of all the stairs. So we can start to embed the carbon strips and stuff like that.
There's a question from Thomas in the chat. He's saying, for example, the well hole in reality, talking about the stair tool, can be built smaller than the stair tool allows us to model it. It's just one example of many. So we're looking for additional methods of creating stairs in Revit. Also, glass stair balustrades are not possible without in-place family cheating. He also says, not sure if Dynamo is the right tool for solving the stair problem, but for special case stairs like this, he thinks it's a valid method. I'm guessing that's more of a statement, Thomas, than a question.
Yeah, the stair tool, again, it's got lots of great uses, but it does have some limitations. Glass balustrades can be really difficult. I have done some pretty elaborate ones with the built-in Revit tools. It takes like a PhD in stairs. As noted, the last session early on, I became the stair guy because everybody else hated doing them. So, hey, it's a stair, give it to Jacob and he'll take care of it. And that's kind of where my on-the-job training came from on that. But you can make it work, but it really does take a lot of specialty effort to really sort of push that content through. And that might not always be the right thing for the job. So when you can implement a solution like this to kind of get the job done in a faster way, I definitely all for it. All right, so now from here, we've managed to embed our carbon strips, but we talked to the client and they said, well, when I look at that in the context of the larger stair, right? So we'll turn on all our geometry preview. It's kind of ugly. I don't really want these metal strips built in there. What are our other options, right? So Sol and I talked about it a little bit, and we said, what if we cut some grooves? So we're going to take the exact same leading edge of the walk surface that we pulled before, and then we're going to take those and we're going to just offset mini curves. Instead of doing 0.125 twice, we're going to do 0.1 3 times. And then we're going to pull the start point and the end point from each one of those, and then draw a cylinder by points and radius. So you can see what that looks like here. I'll turn that on. I'm going to turn off the previous geometry preview up here. And we're going to try and zoom in to see a bit of the details. So you can see we've got a whole bunch of cylinders, again, lined up with the front nosing of my tread because we're basing that off the actual geometry of the tread. We said, go ahead and pull this leading edge for every single one of those stairs.
Well, one nuance about this is because we have controlled the generation of this geometry in the first place, we know it's going to create itself in the same way every single time. The part of the logic that is used to generate both the what do you call it, a carbon strip and these grooves essentially is done in a way that is logical to this specific approach, which means that we know that this geometry is always going to be generated in the same way. Therefore, we can pull the topology in exactly the same way because that flat piece of the surface of the tread itself is a surface. And when we destruct that surface and pull a curve from it, we know that we're always going to get the first curve as being the front face of that surface every single time. If you're coming in with messy data, messy geometry, coming in from, say, an exploded CAD drawing or something, you have to do some kind of logic to be able to pull the correct piece of geometry in the first place. So this does, to Thomas, to your point, behoove you to, if you're generating something really complex like this, to generate it from scratch yourself, because you can really control the process in that way.
Great point, Sol. So then we're going to take our 3 individual cylinders, union them into one, and we're just going to subtract those cylinders from the stair, and we get something that looks like that, which is a little bit nicer looking. We'll go back and we'll preview all the stair geometry, just see what it looks like with the larger context. You can see it on the inside and the outside in terms of how it works overall. It's looking pretty good with things sort of stacking up pretty much as we would expect them to. All right, so now from here, we've got the stuff that's happening down below, but we're going to get to that in a minute because it talks a whole bunch about sort of the logical way to find those leading edges and stuff like that. Sol had a good transition sort of queued up for me there. But before we do that,
gun a little bit.
Before we do that, I'm actually going to just reduce this stair back down to the 360-degree 12.5. And that's again just, I know it works at that size, but as everybody can see with all the solid operations, all the filleting that we have happening here, and all the geometry manipulation that's happening, it takes a really long time to rebuild all that stuff. And I want to make sure I have some degree of flexibility as we go through that.
And not crash stuff.
And hopefully not crash stuff as well, yes.
Zoom is also a resource hog
Zoom
on the machine.
All right, still waiting for this to strip out that geometry and give me my next session.
So in the transition, is there anyone in the chat who has any questions to what you've seen before? Now, obviously, there's some design script we didn't zoom into really deeply, and some Python doing some heavy lifting here. But conceptually, it should be pretty straightforward and pretty simple. We're essentially generating a stair through some revolve methods, and we're starting to sort of dissect that stair or add to that stair using very similar mathematical operations.
All right, so I'm going to go ahead and turn off the preview for those points that I generated before. And now with all of this stuff done, one key piece on the Python here. So I've still got my data gate, and the data gate is going to pass a null over onto this custom node, and the custom node has some logic built into it to sort of suppress any warnings that it might have. So I had to actually build that logic into this, and pretty early on, I just set it up where it says, hey, if something shows up where the run check is not equal to none, or is equal to none, it's just going to go ahead and pass this into the out, and it's not going to bother with any of this stuff, which is one of the reasons why it's running as well as it is right now. But we're going to go ahead and save that, close it. I'm going to open that gate, and then we're going to go ahead and we're going to hit go to see what happens when I don't have null data coming into that node. So the first thing that it's going to do is going to attempt to generate our handrail and center post. You can see it popped up there pretty quick, applied all the textures, and now it's going to start that lovely animation sequence. And I remembered to center it before I hit go this time.
Good job.
Only took like 8 runs through before I had it rehearsed well enough. But
now it's muscle memory.
Yeah, pretty much. So now it's going to go through and it's going to place all those, and you can see the sort of grooves that we put in the treads are actually showing up in the treads themselves. We've got the filleted or edges around all those individual stair parts and pieces. If you're unsure how we sort of got that original shape, I'd recommend going back and checking out last week's session, just because there's a pretty good breakdown of how the logic works for building up a complex system like this. So we're just about done with the first interior loop and we'll start the exterior loop here. And I think I've got one more after this.
And so also big shout out to Dimitar Venkov, and author of the Springs package, for the really cool node that is doing a lot of this heavy lifting.
Yes, the Springs package with family instance by geometry was actually a bit of an inspiration for some of the stuff I was doing in the nodes to produce the handrails. And we're going to pop that open and have a quick look at kind of the big picture steps. I'm not going to get too into the weeds, but I want to sort of walk stuff through because I know we got some people on the call who are pretty technical, and I want to make sure that you guys can get a thing or two out of this as you continue to grow as Dynamo users. All right, so 3/4 of the way through, and we're going to start to see the stair treads that are actually interrupted by the portal into the interior stair.
The transfer beam.
Yeah. Structural concerns certainly, but I think we can make this work. I think I've got one more that's going to generate, and then it's going to lock up and say, hey, I got to think for a minute because you just put a whole bunch of stuff, and it draws my Dynamo geometry. And now you can see these are the individual pieces. I can go in and I can edit these families. They have an import instance in them because of the node that I used, but this one is a little bit different. So we're going to go ahead and we're going to have a look at the inner workings of this one. And do that kind of in the context of Python. Let me change the render mode to consistent colors here. So you can see this actual piece. It's not really the same as our other content, right? I can actually start to adjust this stuff. I can't go too far beyond the end, but I can actually trim the content back, which is pretty nice. This is, again, more editable than what we would get if I was to try and sort of manipulate that with other means. I can go a little bit beyond on some of them, but not as beyond as I might like. I can adjust the cylinder as well. On the cylinder, I can even change the location, right? And all that stuff, again, is fed from this one Python node. So real quick, basically what we do our standard imports as well as the key piece here is to make sure you've got Revit creation family item factory and Revit DB structure, right? These are kind of the two different imports beyond the standard boilerplate.
Jacob, do you very quickly just want to turn off the white space stuff? Might make it look more legible.
Great catch. All right, so to turn off white space, we're going to go to Dynamo, we're going to go to Preferences. I'm going to go into Visual Settings, Features, Python, and then we're going to just disable that show white space, and you see that quickly disabled right there. All right, so not sure what I double clicked on there to get that to pop up at that point, but here we are. So standard module imports, other than, again, the structural type is a little bit unique, as well as the family creation family item factory library. Beyond that, most of these are going to look pretty similar to everybody who's familiar with Python and Dynamo for Revit. After that, we define a sort of interface for family load options, which is basically going to say, hey, if it pops up a problem, this is what I want you to do. So basically it's saying if there's on family found, we're going to go ahead and we're going to set overwrite parameter values to true. If on shared family found, we're going to go ahead and set overwrite parameter values to true as well. After that, we get into our standard inputs. So we've got our document inputs, our temp path, post radius, height, etc., for all the different imports into Python. The key piece here after that is we do a quick check to see if there's any invalid characters in the file path. Again, this is a shout out to Dimitar and the Springs package. From there, we pull open our save as options to make sure we can save the content, create the new family document. So we're not actively working in our doc, we're working in family doc for the most of this. Force quit any transactions we have open, start a new one in the family document, not the document. Try and set the category. And if that fails, let us know. And then after that, create the subcategory, set up our material, and then start to build the railing forms. And the way I did that was we took those points, converted them to XYZs, drew a spline, took a new curve loop and appended our spline into the curve loop. And then basically built the plane for the start of the railing profile and then the curve loop, just like I did in Dynamo by saying plane a parameter, circle by plane. Over here, I'm able to basically pull the plane and draw the curves on that plane. One thing to note, angle measurements in the Revit API are always in radians. It gets me every single time. That was an extra 45 minutes going, why is this not working? This doesn't make sense. But yes, radians every time. Once we've got those pieces done for the profiles, we can sweep the profile along the path to get a form. and we're using the geometry creation utilities library for that before creating our freeform elements for each one of the railings. We do similar for our post, where we start with the sketch plane, and then instead of using the freeform element, I actually use a extrusion. So that's in the family create new extrusion section of the library. We'll close out all the transactions, save our family, load our family into our actual document, close our family, delete the temp file that we save the family to, make sure all our transactions are closed, make a new family instance, and then output that. And that's how we get this sort of editable file that you can see over there, which is pretty cool. All right, so I'm going to go ahead and close that. All right, so now the next piece on that was this node. We didn't really make any changes, except I made sure that I passed my handrail through before I actually started my family instance by geometry. Looking at the time, we've got 15 minutes left. So it's not enough to get all the way through this. I was trying to go quick, but I didn't go quick enough, I guess. But let's talk about how I would go about putting the lights, because I think that's the last thing on the list, right, Sol, is the lights. We covered the treads, we covered the rails, we flexed the stair.
Yep,
all right.
Lights are the last one.
Cool. So to do the lights, we wanted kind of a recessed light inside every third-ish one of our treads, right? So we wanted it mounted kind of on the inside wall. I'm gonna turn off my most of my preview. We're gonna go to kind of our detailed preview only. And we're gonna focus in on the Dynamo side. I also have to turn this off. Nope, that's the wrong one. This off?
You know, you can select it in the background preview.
I could have selected that in the background preview. That's a great shout out. So to do that, we just switch to the background preview, click, and come back here, and then it highlights the node that's actually displayed, which is pretty cool.
And if you use Control-0, you can zoom to fit on those things.
Also true. Also true. Keyboard shortcuts are great. So the way this works is we're going to start by taking all the treads that we made for our interior and exterior treads, and those are kind of a nested sublist, one for the interior and one for all the exterior. And then I'm going to take each one of those sublists, and we're going to unfreeze this, and I'm going to take every third item. So I'm going to go ahead and run this now. Spoiler alert, this one can take a little bit long to get through.
Jacob, Thomas asked, how much does a modern graphics card help to display the background geometry and the nodes in Dynamo? He ordered a new NVIDIA to use for video add-ons and things.
Sol, do you have any ideas on that? All I know is you have to have one, otherwise you might not have geometry preview. But I haven't really tested that content.
I mean, the short answer is obviously the better hardware specs you have, the faster things are going to be. That's just the nature of how things work. But Thomas, I couldn't specifically answer to your specific hardware what difference that is going to make. What you will notice that happens sometimes is Dynamo actually finishes executing things before the rendering kicks into place. You might have a delay of like a half second or a second. So the rendering is actually quite resource intensive. So I would be curious, Thomas, if you wanted to loop back with us and tell us what sort of some relatively complex thing you're doing in Dynamo, whether or not that is faster on the rendering side specifically with your new hardware. Be really curious for that one.
Great answer, Sol, as always. All right, so now you can see I've taken every third from the interior and exterior curve loop, and we're just working with those overall solids. I'm only passing this one for now, just in the interest of time, but if we've got time at the end, I'll go ahead and I'll feed them all through. Panning down and over to here, we're gonna pull the individual faces, and then we're gonna start to filter out those faces based on mathematical stuff, properties about the faces. Because I know my stair, I can start to make those sort of decisions based on what they are. So first thing I'm going to do is I'm going to say, okay, from the face, get the surface geometry, and find the normal. Make sure that the Z value of that normal, rounded to 6 digits, is equal to 0. This is going to get me every vertical face, meaning perpendicular to the face is always going level to ground. Right? That actually edits out a lot of stuff. I had 306 faces before. I'm down to 120. So about 2/3 of the faces instantly eliminated, which is pretty cool. From there, I take the top.
Jacob, one quick shout out. This is a really efficient operation when you're talking about using topology and you're talking about using abstract geometry. So you're getting normals at parameters rather than putting a point at parameter and querying that point's location in space. It is actually going to execute much faster when we do that.
Yeah, great catch. Next piece, because I do actually need to work with points at some extent because they define the location in the 3D extents. I do it a little bit differently though. I'm going to take, for each one of my geometries, I'm going to pull a bounding box. So I don't need to worry about querying the geometry of the surface to find an actual parameter. I'm just going to say, about where are you volumetrically within the model? From there, I can take the max point of each one of those bounding boxes. Again, bounding boxes are defined by 6 numbers, 3 for our minimum point, 3 for our maximum point. If you think way back to about 2 years ago, when we covered geometry in Dynamo, we went over the abstract stuff. So leveraging both topology and the abstract stuff, I can get the Z value for where all of those, the top level of all of those surfaces might be. And then find out what the maximum one of those is for each one of the sublists. And then from each one of those sublists, I can go ahead and I can filter those elements by, is the top elevation at level 2 equal to the actual value for the max, right? From there, I'm down to 48 faces. Right, so we went from 306 to 48 with 2 quick abstract geometry sort of methods.
Efficient processes.
Yeah. Last but not least, I have to make sure I get the right face. So because I've narrowed it down to just the ones that are on the upper level, so they're terminating at the top of my guardrail, I don't have to worry about the ones down here. I've got 1, 2, 3, 4, 5, 6 faces around that curve because I've got the filleted edges. And as a result of that, we can quickly come in and say, hey, with those 6, I want the light mounted on the inside face, not the outside face. The outside face is always going to have the largest area because this is a concentric circle. The inside face is going to have a little bit less than that, and the thickness and the fillets are always going to be much smaller. So I can go ahead and sort all of my faces by the area of the surface, reverse the list, and get the second item in the list that's at index 1. And that gets me down to just 6 faces. So primarily without doing any real difficult geometry stuff, pulling the area of a surface, pulling a normal at a parameter, not too crazy, right? Bounding box of geometry. I can go from a lot of different possible options for where I might want to mount my lights to 6 without any significant issues.
Another thing to bear in mind is that because Jacob's doing this in code blocks, it's actually quite efficient from a memory perspective as well, because every node holds on to all geometry that is in it, and that's by design, so that you can interrogate the geometry and build graphs that branch and have things doing, or have multiple wires coming out of a single node. But it is more efficient if you've fully finished that process to start wrapping these things up into either design script or other processes such as custom nodes, so they don't actually hold on to that geometry and they just pass through the end result.
Nice. All right, so now we're going to take our face geometry, we're going to thicken it to get a solid up here, and that's going to be effectively the volume that I'm going to be cutting things out of. So we're going to go back here and turn off this geometry because I don't want to see it anymore. And you can see this is just the area, this is just the volume in which I'm going to be hosting all my lights. We know where that face is because we've got it here. We've got a solid we can work with as well. And then from there, we start to just use UV coordinates to draw little rectangles on our surface. right? And you can see what those look like. And because I'm using parameterization, it doesn't matter if I'm drawing on the inside or the outside. These pieces are going to sort of geometrically expand as needed. I'm going to turn the previews on and sort of go real quick because I know I'm down to the last like 5 minutes here. I'm then going to go ahead and thicken that polycurve or create a polycurve from those that curve loop that I built, extrude it as a solid, and then subtract it from the other piece, which is going to give me kind of the hollowed out individual shape. I have to go all the way over to the end to disable this bit of geometry preview. Bear with me. So you can see I now have kind of the divot sort of taken out of my solid for the overall piece. We're then going to go back to these curves, get the length of the curves, get the unique items, pull the absolute value of that, get the first item from that list of sort of pairs and the last item of that list of the pairs, and take our depth that we extruded. And the reason I'm doing all that is I'm going to build a function that's going to take the curve geometry of an edge, the length of that curve geometry, ask if that length is equal to this length or the first length of my extruded edges or the second length of my extruded edges, and then filter out my edges based on that. So again, I had 144 options here. After that, I'm down to 48, right? It's actually a little bit more than that. It's 72 edges that I get down to, right? So again, just working with the properties of my edges to quickly filter stuff down and not putting a bunch of geometry in when I don't have to. From there, we're going to make sure all the edges at the top edge of our recess are sort of filtered out. So we're going to go ahead and take the curve geometry, find the point of parameter for the dead center of my curve, get the z value of that and say, is this center of my curve less than the top of my bounding box for the individual solid that I'm mounting my light into, or sorry, individual recess. With that data, we're going to filter out intersections by do they touch the host face or not. The reason for that is I want to be able to fillet my host face differently than my back face. So you can see I've filtered that or filleted that edge by 2 inches. And we talked about the fillet node in the last session. And then after I do the front face, I'm going to go ahead and I'm going to filter the back one. And that gets us a pretty unique looking shape. You can see I've got kind of the swoop in both plan and elevation on the front, but nothing up top. We'll hide both of these. From there, we're going to take our solids. We're going to difference them from our overall solid. So instead of the really big piece, that gets us down to just the little inset void, if you will. And then I'm going to scale that up asymmetrically about the x-axis. And I'm using the x-axis here because this is scaling by a plane that I pulled from my original surface. So now that is also a little bit taller and a little bit sort of more, again, irregular of a curve. And again, that plane was pulled from the coordinate system on my original host face that I picked out from the topology filtering. From there, we're going to filter out to get just our topmost piece of geometry, take our topmost piece of geometry, split it by a thin shell. Thin shell, it's basically going to say, make our exterior wall a little bit further outside, our interior wall a little bit further inside, do that for all faces of my solid. And I get kind of an opening in the middle of my solid. I can take that, union it into one, and then intersect that with all the individual solids that I had for my inside piece, which is going to get me a surface right up there that I can now flatten and join with my previous geometry. So that's this face. Somewhere back here, I forgot to turn off a geometry display, maybe this one. Yeah. I can intersect that with the extruded geometry to get that shape. So now I've got a void shape that has that curve in section, the curve in plan, and a nook into which I can hide my light bulb. right? And so that solid can then be unioned from the individual sublists. And then I can go a step further than that, not that I have time, but I could take that solid and I could subtract it from my larger stairs. And then that's going to give me something of solid that I could bake back into Revit with that void. And now I can, as a next step, host a light fixture that just consists of a light bulb or whatever my light fixture might be from the lighting engineer to go ahead and do that down throw to get the light down on the stair. All right, so yeah, that was everything. Hopefully you guys got something out of it. Again, I was touching on as many crazy aspects of topology and abstract geometry as I could, and tried to stick with nodes and kind of the canvas as opposed to custom nodes. It would have been much easier to sort of build if I'd leveraged custom nodes, but I wanted to make sure we had something that we could point at and start to take apart. All right.
Cool.
So,
all right, this is me. 10
up?
seconds. What's coming up? Okay, writing the stereo story. We want to take the next step in this process and do things with documentation inside of Revit. So leveraging the API to try and automate as much as we can around documentation, which may or may not use the stair depending on whether or not we can host dimensions to it. And then we are still looking for a couple of special guests, but we will get there for packages of note. So packages internal to Autodesk that are really useful that you should probably be aware of. Most of you hopefully are. And then going with the flow, which is the start of a 3-part Civil 3D series talking about pipes. Many more awesome things to come. Please do check out the Dynamo Forum for our post that has all of them blocked out for the entire year.
And then this is just some of the things that we have on the community in terms of how else you can get involved. It's a big long list. I'm dropping some links in the chat if you guys are interested in either attending more community conversations or submitting a proposal or things like that. It's all in the chat. And then after we wrap up, this will be available for rewatching if you guys want, because it was recorded. So we'll get that uploaded onto the Community Conversations event site for everyone. So thank you all for coming. That was a great session. Thank you, Jacob and Saul. And hopefully we will see you all at the next one.
Thanks, everyone. Appreciate your time as always. Hope to see you in 2 weeks.
Bye, everyone.
Bye, everyone.